2, 1. Hello again, my DevNation friends from everywhere in the world. Welcome to another DevNation Tech Talk. We had a break last week because it was Thanksgiving here in the US, but we brought you some amazing content today. And today, directly from Madrid, Spain, we have a very special guest. David is going to be talking everything about Serverless, Tekton, and Argo CD. And without any further delay, David, the stage is yours.
Okay, thank you very much, Edson. Let me share my screen. Okay, so trying to share my screen.
No worries, we know it happens.
Yeah, it's why isn't I can.
The stream bingo, because it's hard to share the screen, sometimes we're on mute, or the camera doesn't work. So if you're watching this, you know that we're doing this live, because sometimes it just really happens.
So strange. Let me guess. I don't know if I can rejoin the call.
Probably, if you want to try, you can drop and reconnect.
Yes, sir, strange. Yes, sure. Just give me a second.
No worries. I'm sure that everybody's super excited to be learning more about Serverless, Tekton, and Argo CD, so just stay tuned. Sebastian is suggesting that I should sing a song, but I don't want you to leave the channel, so I'll just avoid this horrible situation for you. So just keep talking, and if you were here in the US, I hope you enjoyed the turkey last week. If you're not, well, I'm pretty sure it was a normal week, if you can call it normal because of this COVID-19 and everything that is happening. And while we're waiting for David to rejoin, he just did rejoin, and we're having some screen sharing issues, so I hope we figure out. And yes, awesome, we can see your screen now, David.
Okay,
and I'll just stop talking and let you do your presentation. Thank you.
Yeah, apologies for that. I don't know what's going on. Okay. So thank you, Edson, for the introduction. My name is David Sancho. I'm a senior architect at Red Hat Services, and I'm based in Spain. And as you can tell from my accent, of course, is a little bit, it's not native English. So today's talk is based on a two-part article that was published at Red Hat Developers 10 weeks ago. The name of the article was CI/CD workflows for serverless applications with Red Hat OpenShift pipelines and Argo CD. So this means that in case you miss any part of the session or you want to reproduce it yourself at your own pace, feel free to pass by the blog post and follow the instructions step by step. So let's start. I'll give first a brief introduction about to get a high-level understanding of the CI/CD workflow, and also about the technologies and frameworks that they are involved in it. And also, I would like to mention that during the session, I will jump from the demo to the presentation to explain what's going on under the hood. So, which are the main technologies involved in the CI/CD workflow that will be shown today? First one is Tekton, which is a Kubernetes native open source framework for creating continuous integration and continuous delivery pipelines. So Tekton pipelines are cloud native. They run on Kubernetes and they use containers as their building blocks. They are also decoupled, because we could say that one pipeline can be used to deploy in any Kubernetes cluster. Tasks which are part of these pipelines can be reused between different pipelines. And also their resources like parameters, workspaces, and so on, such as Git repos, image registries, can easily be swapped between different runs. In this session, Tekton will be used only for the continuous integration part of the workflow. Then we have Argo CD, which is a declarative GitOps continuous delivery tool for Kubernetes. Argo CD follows what we call the GitOps pattern of using Git repositories as the source of truth for defining the desired application state. In our CI/CD workflow, Argo CD will be in charge of synchronizing the application state when it detects differences between the desired manifest in Git and the live state in the cluster. And finally, we'll use Kustomize, which provide a purely declarative approach to configuration customization. So we'll use Kustomize to enrich how the integration between the continuous integration delivered by the Tekton pipeline and the continuous delivery provided by Argo CD. We'll see that in detail in the following slides. Then about the serverless part, we'll be using Knative, so mainly the Knative project that will provide, for instance, a very simple and rapid way for defining and deploying applications. So in this sense, we'll be using a single object called Knative service instead of having to manage multiple objects such as the deployment, services, routes, and more. And also Knative will provide some automatic scaling up or down to 0. And finally, it will provide a canary route for new revisions to be tested independently. And then our demo application is implemented in Quarkus. So for those of you who don't know Quarkus yet, it provides a container-first approach for building Java applications. And Quarkus applications have a very small memory footprints and fast startup times. So thanks to this, I think it's a perfect choice for developing serverless applications. That's why I choose Quarkus. And also, as we'll see later in the demo, the application configuration is based on 3 different config maps, defined on 3 different levels with different priorities. So in order to consume these config maps, Quarkus includes a very powerful extension called Kubernetes config that will give us the chance, let's say, to prioritize properties from different config map sources. So about the demo workflow. So let's look at each step of the workflow more in detail. So the first step is when a developer pushes a new change in the application source code repository. So then we're configuring the source code repository, which is GitHub in our case. It triggers the Tekton pipeline. And when the Tekton pipeline has started, the first task fetches the source code from the repository. And then a Maven task packages the application code as a jar file and do some unit testing before building the container image. So for building the container image, we'll use a build a task that builds and push the container image to the OpenShift internal registry. So far, it's been all about generating the artifact of the application and also the image. So we could say that it's basically the continuous integration part of the workflow. And then the pipeline continues the execution by cloning the repository where we'll keep the desired state of the manifest of the application that will later be used or they will become the Knative service created in OpenShift and the additional config maps we talked before. Initially, this Git repository might be empty, so this task is smart enough to initialize the repository with the first version of the application manifest. So once the manifest has been created or modified, if it's the second run, this task pushes the changes into this repository. These files and folders, let's say, are structured in a customized way. So as we'll see later in the presentation, is mainly the glue between what we call the continuous integration delivered by the Tekton pipeline and the continuous deployment managed by Argo CD. And finally, Argo CD, of course, will pull from the configuration repository and synchronize the existing Kubernetes object in the OpenShift cluster. At different point in time, so completely out of this regular CI/CD workflow, there might be also changes produced by the operations team. For instance, to, let's say, change one parameter in any config map, the target microservice, or some information that is unknown by the development team. So this last step could also create an out-of-sync state in Argo CD, which would lead to a new synchronization process. That's the step number 10 and 11. So I would like to spend a minute just to briefly explain the structure of the repository once it's been initialized. As I just mentioned, the Tekton pipeline finishes its execution by pushing the desired state of the application in a purely declarative approach into Git. So what we see on the left is the structure of this repository, which is organized with a base directory that contains global or shared descriptors by all the existing environments. And then for every environment, which are represented in different folders, we'll make use of the customized concept of overlays. For each environment, we have a customization YAML for identifying which resources are used for the composition and customization process. These files are then consumed by Argo CD, which then synchronizes and creates those objects in the OpenShift cluster. Well, so far it's all about the workflow, technologies, and so on. So I'll move now to the demo, but I'll come back later to the presentation to continue explaining certain parts of the workflow while the pipeline keeps running. So now, first of all, since we have just 30 minutes for the session, I have already pre-installed the main tools, such as the OpenShift pipelines, Knative, and Argo CD. And also, I have already created 3 different projects or namespaces, which are development, production, and staging, which are basically where we'll deploy the applications. Also, I have created a CI/CD project where I'll keep the Argo CD instance running, the Argo CD server. And, well, in this Argo CD server, let me move to the main dashboard of Argo CD. I have also created 3 different applications. So basically, each application has the same repository for the 3 of them, but they have a different path: development, production, and staging, which is the main where the Argo application will take the sources of this manifest to be synchronized in OpenShift. If I move back to the CI/CD project and then to the pipelines stuff, I have also created the Knative pipeline, which is the pipeline that I have described before, which all the steps identified as a task within the pipeline, and also there are some steps within each task. Also, I have created in an event listener that basically will serve us as a entry point for to trigger the pipeline from a webhook that we have configured in our source code repository of our application. So if this is the everything has been installed through the OpenShift serverless operator. So it's just a very basic Knative serving instance for this demo. And that's, I think, pretty much all from the pre-installation that I have done. So now let's try to run the pipeline from a change that I will apply over the source code. So I have checked out the project, the Quarkus Hello World application. Just I'm gonna, for instance, change the message here. It's gonna be, for instance, DevNation Rocks. I'm going to copy this message because I have to also change the unit test here. Just for a quick verification, I'll run the unit test. Yeah, it has passed, perfect. Okay, so what I'll do now is I'll push these changes from the application to the source code repository. So git add source new version, hit push. So once I push the changes, we'll see the pipeline running in our OpenShift cluster. If I move now back to the OpenShift cluster, CI/CD project, pipelines, here it is. So the pipeline is running, and the pipeline is going to take hopefully between 3 and 5 minutes. So meanwhile, I'd like to explain a little bit, I want to give more details about the structure of the output files that they are generated by Kustomize. So the main object that is going to be generated from the Kustomize files it is the Knative service that is on the right side of the screen. So this Knative service will take the main structure from the Knative service YAML located in the base folder. So this means that every final Knative service deployed to any environment will be built from this base Knative service. As you can see, almost the full Knative service is highlighted because it is taken the whole structure from the Knative service YAML in the base directory. Then for every environment, we'll have a traffic routing YAML that will basically add the main route for the service, targeting the desired revision using different percent or amount of traffic per revision. And as the repo has been just initialized, because we think that this is going to be the first run of the pipeline, we'll only have a single revision behind the main route. And also, for every revision, we'll set some specific details about its name and image. And these elements comes from the revision patch YAML file. And then we also have a canary route, which for this new revision, which is defined in the routing patch YAML. That's interesting because, well, in the first time, the canary route is gonna go to the same revision as the main route. But when we have two different revisions, that's gonna be will give us the chance to canary test that new revision. So that's all about the Knative service composition. But we'll also have some configuration at different levels, as I said when I explained the Quarkus application. So in the base folder, we have a global config map that will be synchronized in every environment. As I said, this is the first iteration of the pipeline. So this config map is empty. We are just initializing this config map. So further changes could be made to this config map, for instance, by the ops team to include some global parameters. And of course, Argo CD will synchronize this new config in all environments. Remember that what we have in the base directory is gonna then be synchronized in every environment. Then we have also a config map per environment, so same as in global. So it is currently empty, and any new change would be synchronized by Argo as well. And finally, we have a config map at the revision level. So this config map has been copied from the application source code repository. So we let developers and how to provide some config and defaults for their applications. And this configuration may be overwritten by these other two config maps that we have explained before. Well, let's move back to the pipeline. See, perfect. It has finished. Good. Everything is in green. That's great. So we move now to Argo. Okay, and we refreshed the applications that they are managing the development environment and the staging environment. We'll do the same in production, but there is one main difference between these three environments. While in development and staging, Argo CD will synchronize automatically all the changes that we get from these source code repositories, I mean from the deployment repository. In production, we'll have to manually synchronize it. I'm not going to do it because I will do a change after testing, development, and staging. We have also, if we move to the topology or developer view and the topology for the Knative service, we can see here that now in development we have a single pod that is basically from the Knative service that we have deployed and the revision that we have just synchronized. So if I move back here, I'm going to get the URL, the main route here. Now it doesn't make any sense to try the canary route. That is the other one that it targets directly to this revision that we just deployed. So I'm going to just do some tests. So okay, here, probably here, much better. Okay. So if I run the test to this URL, don't forget about the path. Well, now it's taking some time because, yeah, Meanwhile, we were just moving from one screen to the other. The Knative serving was scaling down to 0, this pod, so now it's scaling up again to 1. Okay, DevNation rocks, that's true. Yes. In this case, this is going to be for the staging. I'm going to test the staging environment. I will get the URL from staging. The same here. I'm going to use the main route because the canary route doesn't make any sense now. Hello, since we have just a single revision. So again, the pod was scaled down to 0. Okay, good. And in production, so first I'm going to pull the changes in my to my local file system from the Quarkus Hello World deployment repository. So in this case, in production, I'm going to do a change, which is basically I will override the configuration that it comes from the application. Just put it here. Okay. I'm going to copy what it comes from the application source code repository, the configuration that it has been set by the developer, and I will override, for instance, the message for production. Okay. So once we have these changes, I will add them. I will commit them to the repository. So basically, I have done some changes in production. I'll commit and let's say override message in prod environment and git push. Oops. All right. So if we move back to Argo, let's refresh it. We'll force a manual synchronization for this environment, so production. Let's move in OpenShift. We'll see the Knative service should appear soon. Here it is, Knative service. And then we'll see the Knative service revision. Let's wait a little bit. No revisions yet. Here it is. Have the revision. I'll copy the route for this revision. And I'll test this endpoint as well. High production. Perfect. So the main difference here is that instead of having hola as a message, we are having hi because we have overwritten the configuration for this environment. Okay. Good. So next, I'm gonna change the code again because I would like to have a new revision. So for instance, this is awesome. Oops. I'll copy the message well to the unit test. So I create run the test. Okay, this has passed. Perfect. So I will push this change. And what's going to happen is that the pipeline will be triggered again. And message. Awesome message. Awesome message. Okay, cool. So we move back to the pipelines. Pipeline runs. Here it is. New pipeline is running. So again, I don't know how long it took the other one. So 3 minutes. So probably we have to. I have some slides to talk for another 3 minutes here. So let's see what's going on when we run the pipeline again. Okay, so when basically there will be a new folder for in each environment for this new revision. So all the overlays will go for this new revision in these two files, revision patch and routing patch. So the first one, revision patch, will overwrite or will add the revision name as well as the new image. And for the routing patch, in this case, we are including a new canary route, as you see in green, in the right bottom of the screen. But if you look at the main route, it still goes to the old or to the first revision. This is what I was talking about. So the 100% of the traffic still goes to the previous revision for the main route. So what we'll do in the next, once we have the pipeline finished, I will change the amount of traffic for the main route. So we'll see how we can split traffic between different revisions in a very, well, I would say, very easy way. So let's see if the pipeline has finished. Well, we still have some stages to be run. What I could do as well probably is I could show the details about for me, what is the most important task of this pipeline, which is the push knative manifest. This is the custom task that I have just developed for this demo, that it basically do a couple of things, which is cloning the deployment repository. So let's go to this step here. So the first step is creating the base manifest. So that remember the structure of these files and folders, and then we'll create the manifests that are per environment, that are a specific per environment, and finally we'll push all these changes. Well, there are a lot of stuff here. And finally, we'll push all these changes to the Git repository. Let's see the pipeline still running. Well, we are now fetching the deployment repository, and then we'll run the task that I was talking about. One important thing, or one interesting thing, for instance, about Argo as well, is that you could do a rollback based on the history of deployments or synchronization. Here we'll just have a single revision, so I cannot roll back to any revision at all. This is just the first one. And okay, good. We have the second revision now. Let's now see Argo again. Staging and production. Sorry, development and production. We'll refresh it. Okay, it's auto syncing. So we'll see syncing is already going on. And in production, we still have to do it manually. We'll wait for that, as we did previously. If we move back to topology, so let's move back to the development environment. Okay, here it is, the second revision in development, as well as the second revision in staging. So if we see the topology, we'll see two different pods. That's cool. So I'll take I'll copy the canary route just to test that the canary route kind of isolated. So if we move back to the tests, let's just make it bigger. As I said, the main route has not changed at all, even if we have deployed the second revision into the development and staging environment. But if I test the canary route for this new revision, sorry, I missed the path. Okay, this is awesome. This is the second revision. So let's do exactly the same for staging. I could just, for instance, copy the this is for staging. So it seems that everything goes fine. Well, it's starting again. It's scaling up the pods. Oh, again, the paths. Hello. Then hello, hola staging. So once I see that the second revision works perfectly, I will just change. I will pull the changes into the to my local file system, and I'm going to split traffic between the different revisions. That's going to be very easy to be done. So this is the new revision. I'll copy this. So basically, I have to modify the traffic routing file. Remember that if we don't modify it, we'll keep the same main route or the main traffic to the revision that it was previously committed. So in our case, I'm going to change it. So in development, I'll set, for instance, 20% to the previous revision and 80% to the new one. While in staging, just to see some differences in the output, I'll do 50-50. This file is really important because it's the one that is managing the main route. And in production, I'll do a 90 still to the old revision and 10 to the new revision. So I'm going to just commit these changes. Split traffic between revisions. Hit push. Keep testing here. I'll just run the test again here to the main route, which was this one as well. Production still be tested. Okay. And what is important, for instance, I would like to show you let's refresh it, and we'll refresh production as well. Since we have a manual synchronization process in production, one interesting thing is to know what you have changed or what it has changed between pipeline runs. So in our case, in production, what we just did was setting 90% to one revision and 10% to the latest revision. And also, these changes came from the pipeline automatically because we're deploying a new revision. So these changes are fine. I will synchronize it as well. And what we should see here, okay, here it is. In development, we have almost all the traffic going to the latest revision, while in staging, it's just kind of 50-50. And in production, we are just getting some, let's say 10% of the traffic to this latest revision, which is this. This is awesome. So I think that's all from my side. I think it's time for questions, if you have any. And also, these are the list of resources that you could probably consume. Mainly the blog posts, which are, as I said, you could do this kind of demonstration at your own pace because everything is documented there. And then, a list of Git repositories that I have used for this demonstration.
Thank you, Davi. And we had some questions, but I guess most of them were answered in the chat. But we have one last one from Marcel Mauricio. Are these revisions written manually for every build?
Sorry, could you repeat the question?
Are these revisions, I suppose the Knative revisions, written manually for every build, or is it something automatic?
It's automatically. That's something that is done by the pipeline. So when we run the pipeline every time, we'll create a new revision. So we'll remove every revision that it was old, let's say, and we'll just move the customized file to reference to this new revision. So when Argo CD builds the final output, it will take the new revision as a source for the Knative service. So the only thing that we are doing manually, it's in production. We just tell Argo to synchronize when, let's say, we are sure that we want to synchronize those changes. But in staging and in development environments, everything is done automatically.
Okay, and one last question from James Dade, who is one of our DevNation champions. Other than this being native to Kubernetes, what is the advantage of doing this over doing CI/CD with Ansible Tower and Git?
Yeah, well, I think it's a matter of probably preferences. In my case, well, I don't know Ansible Tower that much, so I wanted to test Tekton and the integration with Argo CD. So I would say that there is no answer for that, like do it with Argo or do it with Tekton, or just take Ansible Tower. It's probably for different use cases, but I think it's a matter also of preferences as well.
Yeah, I guess that if you already have a Kubernetes or OpenShift cluster, it's better to stick with the native feature, or else you can use anything like Tower or Git. All right, we are already on top of the hour. I'm glad that the screen sharing in the beginning didn't work, but all of your demos worked perfectly. So we had a very nice outcome of this tech talk. If you're watching this, I hope you enjoyed a lot, and I'd like to thank you for watching us, and thank you, David, for this awesome presentation, and hope to see you on the next DevNation Tech Talk. Bye.
Bye.